Hello, everyone. Welcome to the inaugural webinar of the Global Immersion Cooling Association, or GICA as we call it. My name is Zishan Kadri. I will be the moderator for today's webinar, and I'm also one of the member of the board of directors for GICA. We are very excited to have you join this webinar as we embark on a journey to explore and advance one of the most transformative technologies, battery technologies. Industries moving towards electrification are facing numerous challenges, and the need for efficient, reliable, and safe battery solutions has never been greater. Therefore, this is the reason why Global Immersion Cooling Association was created, and we are committed to supporting different industries and different groups as well. Um, Today, we have great content prepared for you. I have two main speakers here, Arnaud Dorant, who is the president of GICA. We also have Dr. Cecile Pera. She is an expert in the automotive technology and especially in the emerging and new technologies. Before I hand it over to Arnaud and Cecile, I would like to remind you that you can leave your questions in the chat function, which is on top of your screen, and we're going to have a Q&A session at the end of the webinar. With this, I'll hand it over to Arnaud. Thank you.
Thank you very much, Zishan. So yeah, immersion cooling is an outstanding technology, and it requires probably an association to represent this technology and to help the acceleration and the adoption of this technology. Hello, everyone. I'm Arnaud Dorant, CEO and president of GICA, and I'm excited to present this webinar together with Dr. Cecile Pera, with whom I already made some webinar in the past in my company ExOS. So I know that she will deliver very high-level content to you, and I'm excited to share with you the agenda for today's webinar. First of all, GICA, as Zishan introduced, has been created because we do believe that immersion cooling has the potential to break the barriers for the massive adoption of EVs. And our aim, everything starts with a why. Our aim in creating this association is because we do believe that it will accelerate the electrification. And GICA will be presented in detail in the second part of this webinar, but you can already notice that it has been created to drive innovation, promote energy efficiency, and reduce carbon emissions. During the agenda, Cecile will introduce the EV and battery challenges that are numerous, and this world is accelerating fast, the world of batteries. Then we're going to have a look of what is immersion cooling for EV batteries, the advantage of this technology, what GICA offers are, and if you're interested as a company or as a university to join, how to join, and what are the practical next steps for that. I will leave the floor to Cecile that will introduce you to the EV challenges. The floor is yours, Cecile.
Thank you, Arnaud. Hi, everyone. I'm Dr. Cecile Pera, and with me, we are going to do as an introduction to talk about some of the challenges for electric vehicles. So I don't know where you are coming from, but if you are joining this webinar, the chance is that you are very familiar with automotive industry. Would you be a car maker, a supplier, maybe a testing lab? I don't know. But there is at least one thing we can all agree upon is the fact that automotive industry is going through a huge crisis. And I have been in this industry for many years, 15 years and more, and we have seen different challenges, different crises, but this one, I would say, is worse than the other one, and is very different because it's not only the geopolitical and financial problem, it also includes some disruption in terms of technologies, and here I'm talking about, of course, the powertrain and battery, but not only, because we have also more software, we have also more infotainment, and a car maker need to understand how to come to this new area. So in this picture I'm showing here, I extracted from a video I shared on my LinkedIn 2 years ago, where I was comparing the Volkswagen platform PPE with the BYD platform. I took both these videos at the same place at IAA in Munich 2 years ago, and I alerted people on the fact that I was worried that with level of complexity that we can see at Western and traditional car maker, I was worried that we can fight in terms of cost, in terms of margin, in terms of sustainability financially, with a new way to go through automotive industry. And 2 years later, I think we can say I was right. Am I happy that I was right? Yeah, I'm always happy I was right. But I'm a little bit sad because we also could try to work on this earlier. And this is now very, very urgent for everyone to understand that the old way to work in automotive is over and we have to go further in a different area. So one of the common things, I'm going to say that a lot during this introduction, is about a different mindset. Because if you want to be competitive and get affordable EV for people and get margin as an OEM to survive, and I'm going really to use the word survive, you will have to think your battery platform, your cars differently to get margin differently. Can you change, Arnaud?
Yeah.
So one of the first key things I have seen in the industry is the fact that we need more and more integrated component and cleaner design. And this is through all fields that we have in automotive. So I take here the example of GICA casting, where you have now one big place of part of aluminium instead of multiple smaller parts, because it allows you to get a press and stamping of bigger parts, so reducing costs. But this will apply to many other components. So I put, for example, on the top left corner, a 18-1 powertrain that I took the picture at BYD, where you have in this packaging the size of a classical EDU, not only the electric motor, the inverter, but you have, as the name suggests, 8 functions in one, with a DC-DC converter, with the onboard charging, and so on. So packaging at the same place, multiple functions in one component, which allow to reduce the number of parts, but also you can mutualize all the things, all the cooling, all the things, all the cable, so you save a lot of space, but also a lot of money. If we now apply this to battery, we will have the same sort of philosophy. Like, for example, when we talk about cell to pack or cell to body, where you can embed more components in one place. And I also want to draw your attention that cell to body is not the next step. It's not the future. I have seen several cell to body already platform in China, and they are already available. And we are talking here about packaging that are more than 83% packed, already existing today in China. So of course, this makes the platform very different in terms of the mindset. And another thing I want to draw your attention on is that this applies not only for cars, but this applies this new way to think integrated component and cleaner design to any kind of mobility. Would it be in marine? Would it be in aircraft, electric aircraft, and so on? I put here an example with e-axle. This is an e-axle from Tesla, where you get, again, a package that reduce at the same place more components to be more cost effective. Arnaud? So with this change of mindset and this change of component integration, it works together with a change of manufacturing. And once again, this was really well introduced and explained by Tesla already 2-3 years ago with what they call the unboxing method. Instead of assembling in your car one by one, piece by one, you pre-assemble big components and you come to assemble this big package at the last minute in your car plant. And this allows OEM to save a lot of space and a lot of money and makes the way to construct the car very different. One possible example involving battery is the fact that you can attach directly the seat on the battery cover, for example. I have seen nice example coming from Magna, for example, on this. But this means that in terms of thinking of your requirements, you have a lot of new engineering problems. So you have to think about the structure, how it will impact vibration, how it will impact safety for car crash, and so on. So these have consequences in terms of how you package and how you manufacture, but the other way around also work. This manufacturing method will oblige you as an OEM to think your design differently. So, for example, unexpectedly, this will affect people developing infotainment or sound system, because now you cannot put the loudspeaker everywhere in the car, but maybe more embedded in the seat and so on. So you see with this that we have a really shift of mindset, and we need to think the automotive differently if we want to survive in this new area. So now going back to battery, in addition of this constraint in terms of packaging, in terms of margin, in terms of manufacturing, we also have to cope with a lot of other problems that we have usually in automotive. And homologation and safety are really high. So of course, testing for safety for battery fire are one of the main topics still. I have been in this battery test for quite a long time now, and I don't believe there is one meeting I do without talking about fire and safety testing. So we have, of course, the test for different material. Would it be at the cell level, module level, pack level? But we have also tests on single components, like on any bus bar, any coating you apply, any thermal interface material you will have, and so on. And in addition of all these standard tests, you see also car maker introducing their own tests where they are more difficult because they want to prevent themselves against any trouble. So for example, on the bottom left picture, I put here an example of a test I visited at eMobility in France, in Paris, where they combine testing for vibration plus a charge and discharge of the battery plus a cycling of temperature, very cold and very high temperature. And of course, you need to get a successful test, and of course, need not the battery to get into fire as obvious as you get. So the problem is, Arnaud, is that now, in addition of this, we have also more constraints coming from legislation. So the legislation for battery fire are, of course, depending on the market. Would you be in India, in Korea, Europe, let's say China? And again, China is really leading here with very tough and difficult tests to pass. For the last 2 years, people have been super stressed about the detection of runaway and the fact that your battery pack needs to be safe for at least 5 minutes and even more. But I have a bad news for you, is that it's not going to go any better, because if we see what happened in other industries, especially for stationary battery pack, we are now starting to talk about no thermal runaway propagation allowed at all, meaning that if I trigger a runaway on a cell, it's not allowed that any of the neighboring cells go on a runaway too at any time, meaning that you really need to isolate and be really sure of any possible trouble. And rumor, or at least it's a highly probable that we will see further tests also for EV in terms of safety. Arnaud? So now, if you want to cope with all these issues for safety, of course, you have different options. There are tons of things to help you to cope with runaway and thermal propagation. You can put different venting on cell level, module level, pack level. You can embed different sensors. You can have aerogel thermal insulation, or mica, or maybe graphite fin. You can also have different material in terms of composite, which are very resistant to fire compared to metal. You also can get different foam which is very efficient to isolate all these cells. Arnaud. But the problem is that when you combine all these technologies, first you are jeopardizing what I told you at the introduction, is that you need to simplify the design. Secondly, you need to also deal with other constraints, such as life cycle analysis, recyclability, serviceability, and on and on. So I know a lot of people are very concerned when you use some of these safety, especially the foam or the structural bond to stop battery fire, that you cannot necessarily easily recycle or service your battery pack. Just want to draw your attention that it's not necessarily true, because it's still possible to service and still possible to recycle. And you see some data coming from China, especially from BYD, where they compare the time they need to disassemble or service a battery pack with this sort of technologies. It's possible, but the problem is that we in Western countries, and especially in Europe, we are not very familiar with these new technologies, and we absolutely lack of first material to do this. Secondly, of skilled people. And again, I'm very concerned about the fact that we don't have enough education in terms of everything, not only automotive industry, but the general public. And also we need, again, to get this different mindset so we can step back to understand how to design better our EV and battery technologies. No. So now, if we see what possibility we have, one possible path is to say, okay, we need to get these different constraints, and we can add on and on and on different technologies working together. And this is what we have done during the last 4 or 5 years, getting more and more complexity. But you understand, this go against the cost efficiency and the simplification I told you as in introduction. The second possibility is to see the battery pack in another form of design. Would it be cell to pack, cell to body? But also immersion cooling can be another way to design battery pack differently. And this is why I'm not saying here that immersion cooling is the solution. I'm saying this is one possible option, and it's worth exploring because I think it has a huge potential. And I say that based on other industry. So I didn't put here example, but there are already immersion cooling system used for mining or used for off-road. I put here example for cars. So the middle one, the top middle one, is a battery pack from a hybrid Formula One vehicle. I was lucky to be able to see the Formula One battery pack and engine from Honda, for example. And this is a battery pack that uses immersion cooling not only for performance, but for safety. We have also on the left, top left, we have a module coming from a McLaren battery pack that has been through a huge incident, I'm going to say. The car is a total loss, but the good news is that the battery didn't get into fire and was really safe. We have on the bottom a picture of a battery pack made by Rimac for the Koenigsegg that have been through a vehicle fire. So that's a very expensive test of a 2 million car going into fire. But again, good news, this test was successful because the battery pack survived and had absolutely no issue getting burst into fire. And the last example that we can rely on is the fact that immersion cooling is also one of the major paths used for data center and big stationary battery pack, where you really need, as I told you, to be sure that there is no safety issue. So those are examples where immersion cooling is used successfully. And one of the questions is that can we use immersion cooling also for larger volume and so on? And that's why now I'm excited to listen to Arnaud and see what the GICA can offer about that. Arnaud?
Thank you very much, Cécile. That was really interesting as ever. We are talking about immersion cooling, but maybe we have to take a step back and explain the technology and say that there is not a single answer for immersion cooling. There are several kind of architectures. So immersion cooling is diverse. First of all, immersion cooling means that you have a dielectric liquid or gas that is in direct contact with the cells, contrary to, for example, cold plate, where you have an indirect contact of the coolant with the cell. And you have at the bottom of this slide 6 kind of immersion cooling, and you can find more than that. But if we begin by the first image, it's pumped liquid. So you have a battery that is fully submerged in a liquid, and you pump the liquid to extract the heat that is coming out from the cells. The cells are in green in all the image you have here. Then you have the spray cooling. So spray means that you have bubbles of liquid that are sprayed directly on the hotspots of the cells, busbar, etc., with a circulation. The third one is called two-phase cooling, or it has several names: pool boiling, vapor chamber, whatever. You have a circulation of a liquid that transforms into gas when it comes to hotspots, and it uses latent heat from a liquid transforming into gas to be really efficient and manage to extract a lot of heat. If you go down to the graph, you have what we call gap filler. So you remove some glues or some thermal pads, and you transform them into liquid. You use liquid in terms of thermal pads. Then you have what we call static bath. It means that you have liquid inside, for example, a module with no circulation, or inside a complete battery pack. And here the liquid is enclosed. You have no circulation. And the sixth one is called pumped to phase. So you have a circulating liquid that transforms into gas when it's in contact with hot surfaces. These are just 6 examples of various architecture of immersion cooling. So you see that immersion cooling is really wide. And you have the kind of domains that it can address on the right side. So automotive, Cécile already mentioned some example like McLaren. And you know, it is public that AMG is also developing a battery cooled with immersion cooling. Then you have off-road and construction equipment. John Deere last week just announced that they will manufacture their first ever tractor cooled with immersion cooling, full EV tractor cooled with immersion cooling. Then you have plenty of other examples. Sports car, it was mentioned by Cécile. BSS, battery energy storage system for stationary application. Some of them are already cooled with immersion cooling in China, for example. And train, here is not the battery, but for example, in the French or Japanese train, you have the power electronic that is cooled with immersion cooling. So plenty of applications are already cooled, but today it's still niche markets and low volumes. We do believe that for this technology to become mass market technology, it needs standards, for example. It needs education. It needs promotion. It needs a push forward regarding regulations, etc. And that's why we created GICA. What are the advantages of immersion cooling technology? So here are presented 4 main advantages of this technology. The first one is safety. And it was mentioned by Cécile, there is no single battery EV conference where you don't speak about safety. This is a really hot topic. It has to be compliant with stricter and stricter regulation, whatever the markets. Some markets are far advanced. BSS, aeronautics, for example, they are really strict on either no thermal runaway propagation or a really long-lasting time without fumes, smokes, etc. And this is what immersion cooling can bring. You have no thermal runaway propagation if the design is well, let's say, realized for a given cell and for a given architecture. Then the costs. Immersion cooling has the power to reduce the costs in 2 directions. The first one is that you increase longevity of the battery pack because you have, let's say, perfect delta T, really minimize delta T between the hottest and the coolest cell of a battery pack. We've made some example at EXOS where instead of getting 16 Kelvin difference for very high C rates in charge with cold plate, we had only 1 Kelvin difference between the hottest and the coolest cells. So it's really impressive what it can bring. And this transfers into longevity depending on the cycles, on the cells, etc. Roughly all the documentation we've got so far and the test we've made internally, it's always between +5 and +20, 25% in terms of longevity, which if you have a market that looks at the TCO, total cost of ownership, is a lot. Then the other way to reduce the cost is to have a new trade-off for the mobility, at least between range and charging time. We do believe that so far there was a race to increase the range of the vehicle to reduce the range anxiety. And this will continue, let's be clear, in the coming years. We do believe that after 2030, this could be changed with a new trade-off where you reduce the battery pack size. Therefore, you reduce the range of the vehicle, but you increase by far the charging experience with charging time under 10 minutes. And this is for us a very good way to reduce the battery pack size. And therefore, you reduce the cost because you have less chemistry inside the vehicle. The third advantage is performance. You reach very high C rates. We proved for example, with LTO cells that are limited to 4, 5C with cold plate, we proved some tests with 50C. So this is really impressive. If the cells are capable to sustain very high C rates, then you can reach them thanks to immersion cooling. This is an enabler to reach high C rates in charge or in discharge if you have like hybrid application or grid frequency regulation or very high demand on the cycles. And last but not least, if you reduce the size or if you increase the lifetime of the battery pack, this has a positive environmental impact, the benefits regarding the environmental impact, because you will use less battery, less chemistry, and you can get smaller batteries. Not telling that it will be easier to dismantle the battery. Let's say the energy that will be required to dismantle the battery will be lower compared to other alternatives that are glued and that has a thermal pad and glue, etc. But on the other way around, if this technology were magic, it will be applied to 100% of the vehicle. So naturally, this technology has at least generate some fears because this is innovation, and this has also some challenges in front of it. Like, what about leakage? If I have a leak of the liquid that is inside the battery, then I lose all this advantage. What about getting a flammable fluid inside a battery pack that already has flammable cells? So that's a bit tricky, and we need to handle that. Everything has to be, this challenge has to be tackled, and that's why we created the GICA with partners. It's to tackle this kind of issue, to create standard methodologies, to create standard tests, to be sure that we can compare things and that we can accelerate the introduction of this technology for mass market application or for wider markets application, because we truly believe that immersion cooling is the right lever to do thermal management in the future. What are the GICA goals? We have three goals, three main missions at GICA. First one is education. We probably need to explain how the technology works, and let's say that with the fear and the challenges that we have to address, we need to enable people to access to real data, real tests, and to reassure the industrial and the manufacturers that want to use the technology. Second thing is to work on regulation. The lack of standards for this kind of new technology is a real matter when you look at the mass market or at stricter regulated market like aeronautics. It's really hard for the industry to take the development of a new technology without standards. So we need to work on standards. And we do believe that I can give concrete example like, okay, if you have immersion cooling, do you have the right to have the fluid circulating during thermal runaway or not? It's unclear today in the regulation, as immersion cooling is not mass market. It's not really well treated by certification bodies. So we need to tackle this issue and to fix the condition, the methodology, the standards for it. But there is also a need for OEMs to compare different tests being done at different labs. Today, it's impossible to compare a test that is being done in a lab in France with a lab in China, with a lab in North America, whatever. And it's really hard for the OEM to compare results from various labs and various test methodologies. So we have to create standards. This is mandatory. Last but not least is naturally the promotion. And here we want to have really concrete actions with the creation of the first ever annual conference, worldwide conference dedicated to immersion cooling technologies, but also deliver some white papers and participate to conference to educate as much as we can and to promote the technology. These are the three main goals of GICA, and there are more details around the concrete actions that will come in 2025 just afterwards. I just want to give a word on the founding members of GICA. Everything begins with people that are meeting other people that brings a lot of energy to change things. And the three companies that are shown here, EXOS, Lightens, and Carrare. So EXOS is a French-based company, Lightens a Canadian one, and Carrare an Israeli one. And with these three companies, we are talking since 1.5 years to know how we can promote immersion cooling, how we can push forward this initiative, and this leads to the creation of GICA. Just a few words on each of the company. Carrare produce battery system for vehicles with electric thermal management based on two-phase fluid thermal management and immersion cooling. Lightens is specialized in advanced thermal management system. Lightens belong to the company Magna, and particularly they have lots of activities in immersion cooling. And last but not least, my company, EXOS, is set as an expert in immersion cooling with more than 50 projects performed for OEMs and Tier 1 since 8 years now that we are in this domain. But the three companies recognize that there is a lack of standards, a lack of communication of the benefits of this technology, and isolated initiatives. And this is why we wanted to gather the entire ecosystem around us to push forward and accelerate the adoption of immersion cooling. So this association is for you and your company. If you are an OEM, whatever your industry, as it was shown, immersion cooling can be used in lots of various industry, wherever you have a high demand for safety, for performance, for cost, and for, let's say, lower environmental impact. Yes, immersion cooling is required. So if you are an OEM from the automotive industry, from the bus industry, from the boat industry, etc., please join this association if you want to push forward with us immersion cooling. Naturally, for all Tier 1s, all component manufacturers, including cell and pack and module manufacturers, fluid, naturally manufacturers, etc. Certification bodies are also welcomed, because we need for sure to accelerate standard test and methodology for immersion cooling. We need a strong scientific basis and enlarge this with universities or research institute or association. So it's really wide, it's open, and you are welcome if you wish to push immersion cooling together with us. What are the concrete action in 2025? So there will be several kind of actions around them. Networking will be one of them, and second one will be promotion, education. And regarding the next meeting for networking, we have 2 dates in June and in October. 3rd of June at the Battery Show Europe. So for the members that will join GICA until the date, we'll provide a dinner at the Battery Show so that we can meet together. And we provide the same things for our colleagues in North America for the Battery Show in Detroit. And this will be the 7th of October. Then you have webinars. You're going to have webinars in June, July, and November. So the first webinar in June will be around the landscape of immersion cooling. So what is happening? Who are the companies involved? What are the latest news, latest technology advance, updates, challenges, etc. This will be a tech-driven webinar. And we offer the possibility for your company to promote itself through 3-minute pitch, which will happen in July and November this year. You're going to have the opportunity to present your company to all the new members, okay? And last but not least, we're going to organize the first ever international annual conference dedicated only to immersion cooling in December this year, and we're going to fix the dates within 2 months. And this will be naturally the possibility to do networking, to benefits from the latest news, latest updates in this field of immersion cooling. And I'll be more than happy to welcome you at this conference. Naturally, we have some internal rules. So here are only the highlights, and we have a complete document dedicated to the internal rules. But I want to refresh or explain you the spirits and the rules that are behind this initiative. For us, being part of the GICA offers you the possibility to be at the forefront of eMobility. But for sure, as it will be the first year of the GICA, the first year of an association, the association relies on the energy on its members. And until we are a certain number, a threshold, we reach a threshold numbers of members, this will really rely on your energy if you join us. And I hope this will be the case. Reading the rules, we have dedicated document for that. And if you are interested in joining as a member, we will naturally provide all this information. But GICA will not deal with IP, neither with confidentiality. We want every company to be sure and to ensure that people that will take part to the GICA conference, webinar, networking, they are allowed to disclose information that they want to disclose. Regarding the membership fees, which is already something that is interesting for you if you wish to join. So we have two fees, kind of fees. So first of all, I need to repeat that this association is a non-profit one. And the only way to develop this is naturally the company fees, the member fees that will help us to develop this association. So the company fee has been fixed by the board of members at 3,000 euros for the year 2025, which is valid for 12 months. And for a university, this has been fixed at 1,000 euros for 2025, which is also valid for 12 months. When we say a company or a university, it comprises 3 people per company maximum. Okay, and there are additional tariffs if you want more than 3 people to be represented in the association. The next steps, they are really simple. You're going to have all the contacts in the last slide of my presentation. So if you are, and if your company is interested, you please contact us and you will receive application forms and all the information. Then it's like any association. We have a board of directors. The board of directors join monthly to examine the complete demands. And there are 2 possibilities. If the demand is complete and accepted, then it will be finalized. We're gonna give you a green light, and you will become officially a member when the fees are paid. And if it is rejected, I don't expect that we reject companies, except probably if the files are not complete. But I don't see a lot of cases where it should happen. But naturally, we will provide a reason why a company should be rejected that we are not hoping. Board of directors is composed by 3 people of each company of the founding members. So myself, I am the CEO and co-founder of EXOS, a company dedicated to thermal management and expert in immersion cooling. Zishan Quadri. Zishan is from Lightens. He's general marketing manager from Lightens. And Avinoam Rubinstein, who is founder of Karar. As mentioned, Karar is developing 2-phase cooling EV batteries with immersion cooling. So these are the these are the people that are in the board of directors of the GICA. Okay, now we want to take time. We have 23 remaining minutes, and we want to take time to take your question because I'm sure you have some questions. And we want to share with you the way you can reach us. You have it in the end of the slide. So you can reach us through LinkedIn, through X, through our email, which is info@ga-ca.org. Or you can visit our website if you want more information, if you want to learn more about GICA initiative. So thanks a lot, Cécile, for joining me for this presentation. Really appreciate as usual. Thanks, Zishan, for the very good introduction. And now it's time to take your question and to start the Q&A phase. Thank you all.
Yep. Thank you, Arno. Thank you, Cecile. And thank you, everybody, for putting your questions in the chat. We have got a number of questions here. So I'll start with the first question. Either Arno or Cecile, you could take that question. It says, how modeling and simulation contribute to cost reduction and efficiency enhancement, and what major challenges exist in this area?
Well, the question is really broad. Of course, you can use simulation to explore new design. But I think the part where I want to link with the manufacturing is a little bit not necessarily with CFD, but you still can use software for assessing this with, I think especially I know there is a big platform from Siemens where you can try different simulation to see how you can design these things. So of course, there are plenty of companies that can offer platform for testing this in terms of modeling, not necessarily simulation in terms of CFD and 3D. Then I don't know if the question is much more about battery design on itself. I don't know, but if this person can contact me, maybe I can understand better the question. My answer is just there exists a lot of things that can be done.
Perfect. Thanks, Cecile. I think, Arno, you can take the next question. It's pretty interesting and on everybody's mind as well. It says, on the supplier side, we have seen several automotive OEMs halt or slow their immersion cooling development programs. What amount of market share in light-duty vehicles do you see immersion having, and what is the time frame for adoption?
Yeah, this is a good one, and thanks for asking the question. It's true that like any innovation path, it's not a linear way. Generally, you have an acceleration. It's like the numbers of research increase like that. Then you have a slowdown because you cannot reach the right maturity for the new vehicle platform as you would like to do as an OEM. And naturally, it's always easier and safer to take the existing technology compared to bringing an innovation. So our view is that immersion cooling is being introduced by other market than mass markets, than automotive mass market for sure. It's been introduced by agricultural, like mentioned John Deere about Chrysler 2.5 years ago, and these are public information naturally. Kubota invested in eMobility as well, and we see more and more initiative in battery energy storage systems. So we see that the market that are already using immersion cooling, despite 2 million cars, example like McLaren, there are more non-mass market applications, but there are markets where the maturity of the technology is evolving really fast. And so the way we see it, that it's going to be introduced in the automotive industry by sports car or demanding applications, so the upper side market. It was like the turbo has been introduced on premium cars. The airbag has been introduced on premium cars. It's always like that in the automotive industry. When it's an innovation, you don't have the right, let's say, the right costs to propose this technology to mass market. So our feeling is that it's going to be introduced for sports car and premium, and then beginning from that, it will be introduced to mass market. So maybe if I answer in terms of date, we see sports car application is gonna begin with let's say interesting volume next year with a German OEM, and between 2026 and 2030, we anticipate this will be still sport and premium. And after 2030, we do believe that it will widespread to mass market.
Thanks, Arno. I guess you answered the second question as well, which is regarding what OEMs are working on the immersion cooling technology. Cecile?
Just want to add that I have seen from China battery packs that are immersion cooled that should be, I don't know what sort of volume, but China is always, for us, large volume. That should be immersion cooling by the end of this year or next year. So it's coming really for larger volume, definitively, also from China.
Do you know any particular OEMs who are working on it?
Anyway, I cannot say for NDA, so.
All right. Okay. No worries. Okay. So I know, I guess there are a number of OEMs in the US and EU. Again, I cannot name them as well, but they are working on immersion cooling as well. So I have another question here. It says, how do you deal with compatibility and weight increase?
That's a good one. Yeah, regarding material compatibility, We've been testing, for example, for various OEM, more than 30 plastic elastomers, etc., with plastifiers, with aging methodology to do several thousand hours of tests to be sure that even with aging and plastifiers that will be released, etc., the liquid will still have their properties. So I think this is well covered and well identified. This part. Second part is, can you repeat, Zishan, the second part of the question? It was weight.
The weight.
Yeah, weight.
Yeah, weight.
The weight.
Yes.
So yeah, we've made a lot of studies that shows that if it's well packaged, you don't have, you could have between -2% or +2% of weight. So it can even be lower. And our feeling, one more time, is that we need to reduce the battery pack size because of resources that will be scarce. I mean, with 10 to 20% market share in most of the Western countries for EVs, we still have the resources. Will it be the same case if we have 50% or more for many, many countries of EVs after 2030? This is unsure. You know, the resources, lithium, manganese, cobalt, etc. We are not sure exactly about the real resources that are available. So our true belief is that we need to reduce the battery pack size. And therefore, this will reduce weight directly because we're going to have less chemistry inside the battery pack.
Right, makes sense. We have another question here, and a few people have asked this question: how modeling and simulation contribute to cost reduction and efficiency enhancement, and what major challenges exist in this area?
Yeah, sure. The Chinese, with their capacities to develop within 2 years new models, new EV models, put a lot of pressure on the development time on Western OEMs and tiers. It's true that generally we are more at 4 years in Western countries, and reaching 2 years is a new target, and this requires lots of simulation, but also a lot of modular approaches. This is not only simulation; it is also to have common bricks like Lego that we will assemble together to save time. And bricks that are validated to avoid also to take industrial risks in terms of quality, in terms of safety risks, etc. So yes, modeling coupling to tests and directly, let's say, digital twin coupled to test is a must. And in immersion cooling, this is a new era where there are a lot of opportunities for companies that are really skilled in doing either test or simulation or both to provide this value to OEMs, because this is required to help them to save time. Sure.
Thank you. Vinod, I think this next question, you can take it. It's about two-phase immersion cooling system in lithium-ion batteries. The questioner asked, given the challenges associated with two-phase coolants, do you think this technology should be reconsidered or abandoned?
Yeah, thank you for the question. And thank you, Arnaud and Cecile, for a great presentation. I do appreciate it. I think that this association could drive the adoption of immersion cooling. Back to the question, so definitely two-phase technology has a huge advantage as far as heat dissipation and the performance it kind of allow in the system. One of the challenges that has been raised is actually the capabilities of different coolants or refrigerants to meet the common standards, mainly PFAS. And the chemical industry actually addressing, and they actually took this challenge. So we are expecting to see new coolant, new refrigerants that actually meeting both the classical standards from ozone depletion percentages and GWP, and of course PFAS. So we actually working with a variety of chemical companies that are actually going to deliver PFAS-free or very, very low PFAS solutions, and actually already delivered very low PFAS coolant. So that's something that going to be solved in the next few years.
Right. Thanks, Avinav. Next question, either Avinav or Arno, you can answer. Which dielectric fluid is better in terms of cost point of view and better heat transfer?
The one that provides the best added value and cost benefit performance. It really depends on the application. If it's let's say, imagine if it's for safety only with low C rates, then maybe single phase or most appropriated. If you have very high C rates with hotspots with high thermal flux, then two phase can make sense. So it will be compromise with the architecture, with the targeted solution at the end of the day. Yeah. And after that, there are other considerations, as Avinoam just mentioned, regarding the environmental impact or not, recyclability, because Cecile mentioned that LCA is also something that needs to be considered in the future in Europe, as well as serviceability, or let's say recyclability of the fluid itself. So there are many criteria, but yeah, we know how to compare fluids and solutions if you wish to contact me directly. Yeah.
Yeah, so someone is asking if you could elaborate on the serviceability part.
Regarding immersion cooling, yeah, it's like if you take the example of single phase fluid, there are like oils from transmission gearbox, and so serviceability is already worldwide for any ICE cars. You have this kind of already existing supply chain, and fluid for immersion cooling in batteries. There are let's say fluid for life or fill for life. And therefore, you normally have no serviceability. The only question is after 10 years in a car, if you want to reuse the battery for second life, like in photovoltaic storage or wind farm storage, then maybe you need to change the fluid, but it's like a normal change of oil. So there is no hurdle here. Yeah. But normally it's sold for the entire vehicle life.
All right.
So maybe I just add that actually using immersion cooling from the battery serviceability point of view, it actually makes better architecture that allow you to service a specific cell or module, which existing design actually do not allow that to do that because of the modularity. And of course, we're all using kind of the normal processes of either HVACs, brakes, and other liquid base or fluid based systems in existing vehicles today.
All right. There's another question on spray cooling approach. Which opportunities and limits do you see with spray cooling approach? Does it have a chance to success among the other different immersion cooling approaches?
Yeah, that's a really technical one. I think it's hard to understand. Yes, this technology will win, this won't. This is something that we want to offer at the GICA, compare technology, making cost, weight, impact analysis, and provide a clear vision for a given application or for various applications to let's say the entire ecosystem. But you have to imagine that this kind of study, we need members to let's say to fuel this kind of information inputs and to be able to develop this kind of studies. We have naturally answers at EXOS for some given cells, given architecture, given cycles, but it's never a general answer, I would say. It does not apply for 100% of the use case we see.
Right. Well, another interesting question here. Is it possible to implement liquid immersion cooling for swappable battery pack application? Good option for making immersion cooling more popular.
Yeah, this is a good one. For example, if you have non-circulating fluid, if it means that if you have modules and non-circulation fluid, yeah, this seems a good match, a good couple to answer this kind of swappable batteries. And then there are always, let's say, stop leaks connectors, etc., that exist, but for sure it makes it harder in terms of quality, in terms of reliability, etc. So yeah, probably with non-circulating fluid, you can reach this swappable battery with a high level of quality and reliability.
So, Arnaud, may I add that I'm aware of companies that actually doing immersion cooling solution for swappable services as we speak.
In motorsport also, you see some people trying this with swappable immersion cooling, but the difference is that it's not fully automatic. So you get someone swapping and plugging in and on. So it depends if you want this to be fully automatic or not, obviously.
Okay. There is a question on risk associated with immersion cooling. I know Arno and Cecile, you touched some of the points here, but they're specifically asking about fluid leakage and any material compatibility issues.
Yeah, I think fluid leakage is it is a killer of this application. I mean, if we are not able to provide batteries without leaks, this will not enable this technology to survive and to develop and to. But this is not what we do believe. I'm not telling this is easy. On the other side, this is not, let's say, we manufacture the things that are more complex than ceilings for this kind of applications. So yes, you have to cope with minus 40 degrees Celsius, plus 50 degrees Celsius, etc. So there are different constraints, etc. But companies like Freudenberg, Zimrit, etc., they are really good at developing let's say, ceiling solutions that cope with this kind of constraints. So for sure, we have to take care about this because in the DFMEA, if you have a look to the failure mode analysis, for sure, if you don't have any liquid inside the battery, then you lose the technology advantages of immersion cooling, and this is one of the major risks. On the other way around, it's not rocket science to fix it. Even though it's not so easy, it's not rocket science, and we already have solutions that are in the field since many years with no leakage.
Right. So the next question is on technological trends. Maybe Cecile, you can take it. Is industry currently considering combining the cooling of the battery pack and electric motor?
Yes, many people are trying this and have explored this that I'm aware of. So the dream of some people is to say that we could get a unique coolant for doing multiple purpose, and it works very well with what I say integrated component if we can combine everything at the same place. But again, this will bring challenges because the range you need for battery are different from the one you need for electronic, which are different from the one you need for electric motor, which are different from the one you need from the cabin. So with some trick, it's possible. Generally speaking, I think this question goes to how you will simplify the global architecture. And it's not necessarily what it's, in theory, everything is possible from an engineering point of view. We are engineers, we solve problems. So we can solve this problem. The only question is how you cope that with what I say in terms of margin and in terms of manufacturing. It's possible technically, of course, but is that the best way to do? Maybe, because it can offer cost reduction for other things, but at the same time, be careful not to add too much complexity over engineering things because you want to achieve something very difficult that will not be necessarily easy to compete in terms of cost with maybe some other solution.
But for sure, this, if I may add, this is one of the vehicle integration is one of the challenge. Adding a fluid in a vehicle for serviceability is a challenge. If you already have water glycol for the other components, adding a dielectric fluid is a challenge. In terms of supply chain, it's another fluid in the car, which is never wished by OEMs. And once you have the battery with dielectric inside the vehicle, you need to figure out to take the maximum advantage of it and probably cool the power electronic, cool the e-motor, except that the e-motor, you also need to have the lubricant function for the gears. You need also, so you have to separate things because you cannot throw some, let's say, metal sheet parts inside the fluid that will transform it into a conductive fluid that we want to avoid. So yes, there are plenty of initiative, and one were presented at the IQPC Munich by Valeo and Total Energy 2 weeks ago, where they have works on getting only one fluid for cooling all the components. So yes, there are many initiatives in this direction.
All right, well, thank you, everybody. So we're just 1 minute left before we end this webinar. So we thank everybody who joined this webinar. We believe that immersion cooling is a crucial enabler for the future of electric mobility, and we're happy to work with you. We welcome you to join the GICA as well. You have all the information. We will share the presentation, and there are other questions pouring in, but we will try to put them together and get back to you with some of the answers here. Thank you once again, the speakers as well as all the attendees. Have a good day.
Thank you very much. Have a good day.
Bye, everyone.